Hello, everyone. Welcome. I hope everybody's having a great time at reInvent. Thank you for joining our session. We're going to be covering the security frameworks around Wel-Architected framework and the cloud adoption framework. My name is Steve Lano. I'm a security architect with the Global Security Risk and Compliance practice in AWS Professional Services. And my role is to help customers build the confidence and security capabilities that they need to migrate their most sensitive workloads to AWS. I'll also be presenting with Ivan Sekulic from National Australia Bank, who'll tell us about his cloud journey, and Ben Potter, who's the security lead for the Wel-Architected framework. So our objectives today are to help define a security strategy for your migration to AWS and be able to implement AWS security best practices in your environment, as well as help you to understand how to implement security services at an accelerated pace. Also, we're going to be getting some code from Ben as he goes through his session, and that'll help you guys to implement and automate some of the best practices that we're going to cover. So at AWS, we always start with the customer and work backwards from there. So we're going to hear from Ivan about his cloud security journey. And then we're going to do a deep dive on the cloud adoption framework, security perspective. And then Ben will do a deep dive on the Wel-Architected. So I'm going to hand it over to Ivan.
Thanks, Ray.
Thank you, sir.
Cheers.
All right.
Hi, everyone. Thanks, Steve. So thanks so much for coming to the session today. My name's Ivan Sekulic, and I'm a security architect at National Australia Bank, which is better known as NAB or just NAB. As a financial organization, we've been on a cloud journey for quite some time now, and we've achieved quite a lot. So I wanted to take just a few moments of this session to share a bit of a success story with you guys, and maybe you can derive some insights from it that you can use in your cloud journey, wherever you are with that. So just as an introduction, if you haven't heard of us before, we're Australia's largest business bank. We're one of the big 4 banks in Australia. We have over 30,000 employees, around 9 million customers, and we operate at around 900 locations around the world. So like all banks, we're heavily regulated, and we see the breadth of security threats that you read about in the news. Cybersecurity is important to our business, to the extent that it is one of the top risks that our board monitors very closely. We absolutely recognize that we're an institution of public trust. Our customers trust us with their money and their data. And if we lose that trust, we can't be successful. And we know that cloud security plays a key role in ensuring that customer trust. And as you would expect, it's a key pillar of our enterprise security strategy. So a bit of history with us. We started our cloud journey back in 2012. We've taken an iterative approach to cloud adoption since then. And over this time, we have an ever-increasing footprint in AWS. In 2012, we migrated our flagship public websites, nab.com.au and mlc.com.au. And I know that sounds trivial now. I can certainly say it was a huge cultural shift for the organization. By 2016, we were building and deploying our transactional workloads in AWS. These are the workloads that support the majority of all digital interactions our customers have with us. And since then, our journey has gone into overdrive as we've experienced an accelerated push into cloud and a cloud-first approach to all technology in the bank. So to support this cloud-first approach, we knew that our current security strategy had to change. Using our traditional methods, there was no way for our security teams to scale to meet the demands of the business. So we went back to the beginning to develop a new cloud security strategy, and we used the cloud adoption framework, EPICS, as a starting point. We stole liberally from the CAF and AWS Well-Architected, and from it, we developed some of our own key focus areas to deliver on. So I just want to list some of them. So our first key focus area was we knew that we needed to extend our existing security services to the cloud. So this means that all of our security teams had to establish their own competency in AWS. So this allowed our security teams to be there as our technology teams built and developed applications. This competency allowed us to build native security capabilities to use the cloud, to secure the cloud. Secondly, we focused on being integrated and secure by default. So we knew that security must be baked in and not bolted on. Security couldn't be an afterthought. It had to be part of the fabric of the applications and platforms that our dev teams were building every day. And this mentality allowed us to be secure by default and deliver security at every layer. And finally, we focused on continuous security governance. So for us, that meant building self-service dashboards, providing reporting and visibility of the current state of security controls and posture to our development teams to give them a full understanding of what they had and allowing them to take responsibility. And it had to be continuous governance, always updated in real time. So taking this iterative approach to cloud adoption and a new security strategy turned out to be a great combination for us. We achieved some great things along the way, and we learned a number of lessons. I think I want to share 3 of them with you now. So we found that NAB's ability to adopt cloud at scale is a function of our ability to secure cloud at scale. The business wasn't able to do it without us. And in NAB, an order of magnitude more AWS developers are coming as a result of internal training programs, like the NAB Cloud Guild, which since starting in May of 2018, has trained more than 3,000 NAB developers. And out of that, 400 have obtained certification. So as a result of that, an order of magnitude more applications are being built in the cloud. So without changing our approach, there was no way to scale the security practice to meet that kind of demand. We also invested heavily in automation and decentralization. So we know that humans are great, but they certainly don't scale. Our goal is to automate everything we can. And we replaced all centralized models with decentralized ones. We understood the value of automation. It's our force multiplier. And lastly, our security practice had to learn to iterate and evolve. We proved that security controls and governance do not have to be at odds with agility and innovation. In fact, we think good security enables that. We had to learn to start small, iterate, evolve, and lean in. We avoided analysis paralysis by not being afraid to fail. And I can tell you that our security strategy today looks very different to when we started. Even the security architecture team that I'm part of had to change. So we had to change from being a box-drawing organization. We had to learn that our security requirements that we deliver had to be articulated well enough that they could be expressed as code, which allowed our dev teams to build that into their applications, and our governance teams to validate it. So armed with this experience, our cloud security team recently joined forces with AWS Professional Services to build a continuous compliance solution within the NAB. This solution allows us to systematically and continuously review the security compliance position of every AWS workload. The solution allows someone like me to identify a risk or a gap of the solution, articulate a security control, have it built as code, and delivered really fast. It gives us a real-time view of security compliance across the whole enterprise, and it allows our dev teams to deliver as fast as they want without being forced to use extra control planes or API brokers. So we trust, but we verify, and we can verify proactively, reactively, and retroactively across the whole organization. By leaning into the lessons that we learned along our cloud adoption journey, we enabled enterprise-wide security updates with the push of a button. And we did this using entirely AWS native services. Ultimately, it's allowed us to reduce the deployment time for an enterprise security control from 19 days to 45 seconds, which is a 35,000 times difference. In fact, this effort's been internationally recognized as it recently won the Regulation Asia Award for Excellence in the category of cloud innovation. So we started our journey back in 2012, before the CAF was even around. And looking back, we started by defining our strategy and identifying our first workloads. Since then, NAB has gone cloud first, and security had to be right there along with them. When we needed to change our approach, the cloud adoption framework and well-architected principles guided our security strategy. And now, with continuous compliance, we have the CAF security epics and the well-architected security design principles covered in depth and baked in at every layer. So thanks for that. And now I'll hand it back to Steve to run you through the Cloud Adoption Framework and the epics.
Thank you, Yvonne. Really
Cheers,
appreciate
mate.
you telling your story. Thank you. So how many people here have heard of the Cloud Adoption Framework? Okay, great. How many people have actually read it? Okay. All right, one of your takeaways for today is going to be to go back and download that. We'll provide some links at the end. Highly recommended that you read that in depth. So the Cloud Adoption Framework is a structure that AWS put together to help organizations to develop and implement an effective and cohesive cloud adoption journey. The Cloud Adoption Framework is divided up into 6 individual, what we call perspectives. There's a business perspective that helps identify business outcomes, a people perspective that helps identify and build a strategy for HR and skilling up the organization. There's a governance perspective that focuses on the delivery model for the overall cloud migration, a platform perspective that identifies the infrastructure and technical aspects of the cloud journey. The security perspective, which we'll be focusing on today, identifies security risk and compliance requirements, implementation, and security governance around your AWS environment. And the operations perspective that identifies and helps customers with their journey in operational processes and procedures. The security perspective of the Cloud Adoption Framework, which I'll refer to as the CAF from now on, is divided up into 4 areas of focus. There's a directive, preventative, detective, and responsive. What these areas of focus allow you to do is to help you organize your controls and your cloud adoption journey from a security perspective. So directive controls help establish governance, risk, and compliance controls and processes that you need to establish in order to meet your current security requirements. Preventative controls that help to protect your workloads from threats and vulnerabilities. Directive controls that help provide full visibility into your environment, inventory, and change management. And responsive controls that help you respond and recover from deviations from the baselines that you establish. The CAF also identified, what we identified in the CAF after working with hundreds of customers around the world, we identified a number of themes that we call out in the Cloud Adoption Framework. And those themes focus in on identity and access management, detective controls, infrastructure security, data protection, and incident response. And these controls are organized and implemented and executed in an agile methodology. And we'll cover that a little bit in the next few slides. We also have the shared responsibility model. How many people here are familiar with the AWS shared responsibility model? Okay, great. That's, wow, a lot of hands. Very good. So this is an important cornerstone for implementing your cloud journey and utilizing the Cloud Adoption Framework to build your strategy and execute. And what it does is it basically delineates the security responsibility between AWS and the customer, where AWS is responsible for building and maintaining the security controls from the hypervisor down to the physical infrastructure. And our customers are responsible for building secure applications and protecting their data. It's important to note that AWS makes available a number of best practices, such as the Wel-Architected framework that Ben will present in a few minutes, as well as services and features that help customers to protect their content and build more secure applications. So when I was a customer, and the customers that I talk to today, I see a commonality in the questions of, where do I begin as a security architect or engineer? Do I need to rewrite all my security policies and standards? How do I get the same capabilities that I have on-premise that I do in the cloud? How do I get there? So the Cloud Adoption Framework actually will not only help you answer all those questions, but it'll help you define an organized, cohesive security strategy, and then help you implement that in your cloud environment. And it does it in an iterative way. So essentially, we start by identifying our stakeholders in our organization that are responsible for various security capabilities. For example, threat and vulnerability management, intrusion detection, anti-malware, right? Identifying who's the parties in your organization that are responsible for building those capabilities, and then also identifying the parties that are responsible for operating those capabilities once they are built. The second step is to identify the workload type that you're going to migrate to AWS, and identifying the security controls that are commensurate with that workload and the data classification that it might be running. So once you've defined your initial strategy, your stakeholders, your RACI, for responsible and accountable for each of your security capabilities, and you've identified the workload types that you're moving, it's time to inventory your security requirements and policies, identify any legal and regulatory requirements that you may have for your particular organization. Think about your organization's risk appetite and how you approach security today. And taking those security requirements and combining them or pairing them with your data classification policies. And then identifying which controls that you require in your organization that are commensurate with the particular workload that you're moving. And by doing that, you're establishing your initial minimum security baseline. We establish our minimum security baseline by either using an organizational security framework that you might already be utilizing, or adopting a common, well-known framework such as the Center for Internet Security, Critical Security Controls, or ISO or NIST 853. Taking inventory of those controls and mapping them to your current policies, and identifying the capabilities that you need in order to meet those security requirements, and then mapping those further down to specific services and features that you need to implement in your cloud environment. So once you establish this mapping, you basically have what you need to get started on your journey of actually implementing security controls that are commensurate with the type of workload or data classification that you're moving to AWS. So some of the best practices, again, are inventorying your current security controls, inventorying your current security policies, identifying any legal or regulatory requirements that you may have, your company's risk appetite, logging those or mapping those to the well-known framework so you could identify the specific controls that you need to implement in order to meet those requirements, and identifying those workloads again, identifying the workloads that you're moving and mapping those to the control spreadsheet, and identifying the stakeholders for those security capabilities. It not only helps you to accelerate the strategy and implementation, but also will help you identify gaps in your requirements. For example, if you have a need for a capability such as, again, anti-malware, but you don't have anyone in your organization that's responsible, it's going to be blatantly clear in the risk register that you need to find somebody that's going to be responsible for helping to get that implemented in the cloud. So we've identified our requirements. We've identified our workloads. We've built a mapping chart that's going to help us to identify the specific controls that we need to build up front. And the next step is to deploy our architecture, and in an iterative way using the Cloud Adoption Framework Security Epics method. And what that does is that helps us to build our security controls and meet your compliance requirements in your AWS environment in an iterative way, and building upon previous iterations to create more robust and complex security controls, and building in automation as you go. So a sample security epics journey might look something like what you see on the screen here, using an agile methodology. In the first 1 or 2 sprints, we would focus more on identity and access management, since it is the top priority of the 5 epics. In a traditional environment, you build a server and you provide access credentials to a developer or an administrator. In the cloud, that paradigm is kind of switched. You create your credentials first, and then you give access for people to create their underlying infrastructure. So in the first few weeks of the sprint, you'll implement identity and access management controls that you've identified in the mapping exercise. So for example, things like creating roles based on job functions might be something that you do in the first sprint. Federating with your on-prem LDAP service might be another item that you would do in the first sprint. And then once the identity and access management is established or begins to be established, we can start moving into other controls like detective controls and maybe centralizing our logging or turning on CloudTrail in all regions. And then as we move along the journey, we start to implement more heavily into infrastructure, data protection, and incident response. In infrastructure, we would do things like building security group strategies, WAF implementations, routing tables, network access control lists, those types of controls. And then when we're ready to start putting our data into the environment, once we've built up the identity and access management and detective controls, we look at things like turning on encryption for S3 and EBS, encryption in transit using TLS. And then we look at building incident response plans and incident response plans and procedures to help remediate any deviations from the baselines that we establish. So as you progress through the sprints and you iterate, again, you'll build more complex controls and automation into the environment. So I'm going to turn it over to Ben now, and Ben is going to talk about the Wel-Architected framework and the best practices that are used to implement the cloud adoption framework and security epics across your environment. Thank you, Ben.
Thank you. Thanks so much, Steve. Nearly dropped the clicker then. Right, so everyone's heard of Wel-Architected because you're here and it's up on the screen. Who's actually read one of the white papers? Great, awesome, very good. So Wel-Architected, like many things at AWS, we've created from 10 plus years of experience in working with our customers, listened to our customers, and actually fed back the architectural best practices and those lessons learned into this framework. And we continue to iterate over the years on this framework as well. So the framework consists of 5 pillars, in which one of them is security, and design principles. As Ivan mentioned earlier, National Australia Bank used these design principles throughout their architectural journey. And most important thing for the framework is it contains a number of questions. So these questions within those 5 pillars allow you to self-evaluate your architecture, because they're also coupled with best practice answers. And these answers can help you assess and evaluate and continually improve your architecture running in AWS. So the 5 pillars, we start with operational excellence. So it's really important to get your business priorities right first. Is security the most important pillar for you to get right first? If you're a financial institution or healthcare, security is definitely going to be your most important one. If you're a startup doing a mobile gaming app, then perhaps performance and cost optimization are more important for you. Then we move on to security, reliability, performance efficiency, and cost optimization. Now, it's cost optimization, not reduction, because you need to assess your architecture and optimize over time and make sure you have the best trade-offs between the different pillars. So at Amazon, we like to talk about mechanisms. So mechanisms are a lot better than just good intentions, because good intentions don't last, right? So it's a mechanism for your cloud journey. It helps you learn from reading the framework, reading the white papers, and through the questions, you can self-evaluate and continually improve your architecture. So let me walk through the security design principles now. We have implement a strong identity foundation. It's absolutely critical that you get identity and access management right from the start. Having logging, monitoring, alerting, and response allows you to have traceability and know what's going on inside your workload. Applying security at all layers. So this is defense in depth, right? Don't just put a firewall on the outside of your architecture and trust that firewall is going to block everything. You need to go through and secure every single layer. If you're running EC2 instances, you need to apply hardening to those. If you're running your own code or bringing in external libraries in your code, then you need to scan those for vulnerabilities as well. Automation. So again, Ivan mentioned that NAB are using automation as their force multiplier for their security team. You can only do so much with people like you and I, right? Protecting data in transit and at rest. And typically this is encryption, so you want to encrypt all your data in transit and at rest. Encryption in AWS is ubiquitous. It's very easy to enable and is built into the platform. Keeping people away from data. What we mean by this is keeping end users away from directly accessing data and systems, and even administrators. So not logging into instances and running commands on SSH or remote desktop manually. And finally, it's being prepared for responding to an incident. So incident response. And it's absolutely critical that you're prepared before the unlikely event occurs. So that's an introduction to Wel-Architected, the framework. Now I'm going to go through a bunch of security best practices and actually how to achieve them, how to implement them. Watch out for links throughout this, and the session is recorded, so if you do miss any, you can refer back to them later. So starting with the strong identity and access management foundation, you want to lock away your root user. The root user has full access to your AWS account and should never be used. There's only certain circumstances, such as enabling a support, that you need the root user. Definitely consider using AWS organizations. So organizations can help you manage not only the cost, like consolidated billing for multiple accounts, but also the security of multiple accounts. You can apply service control policies to stop other regions. If you're don't want to run in other regions, you can apply service control policies, for example, on regions and services to stop people from using them in your accounts. You also want to set the security questions and answers in your accounts in case AWS needs to reach out to you. You want to have centralization of identity and access management. So having a federated identity provider or directory service and centralize those credentials for all your users. So by doing that means you don't have to manage credentials in multiple locations. So for me, you have an email service, you have one credential. You can then use roles, and I'll talk about how you can use this shortly, to use that same credential for your users in accessing multiple AWS accounts at scale. You also want to audit what credentials are there. Did you create something a few weeks ago or a few months ago just for a test and leave it there? So you want to go back and audit the credentials and make sure that only the valid authentication credentials are there that you need at that point in time. Never, ever store any secrets or any passwords or anything like that, any access keys in code, ever. So you can use AWS Secrets Manager to handle this for you, or even KMS, a key management service for managing encryption keys. You want to enforce multi-factor authentication using software or hardware tokens on everything. And I've got a quick demo on how we can do that shortly. Using roles for IAM users, if you're not using a federated provider, allows you to enforce multi-factor authentication. You also want to establish least privilege policies. So if an administrator doesn't need to manage identity and access management users or policies or roles, don't give them that access. And you also want to use temporary credentials. So if you're using roles, you're already using temporary credentials through the security token service. If you're developing something yourself, if it's a mobile application, for example, you can use Amazon Cognito to handle that authentication for you and the rotation of those credentials. So how do you enforce MFA for an IAM user? You have the user with the MFA token and a password. We then apply a policy that looks something like this. We have an action which only allows them to assume a role. And they can only assume that role when there's a condition of the MFA token is present. So even if I accidentally put my access keys for that user somewhere that I didn't want to be accessed, I'd still need the MFA token to be able to assume this role. And the role itself has a condition in which it requires MFA to be present to be assumed as well. And then that role itself has the actual permission that you want to achieve. In this case, it's a read-only permission. And that's what gives me access into my environment. So moving on to traceability now. The easiest way to get traceability from the start is just enable guard duty. So you get a free trial within your accounts, enable it. It will automatically look at the VPC flow logs. So it will look at traffic flow in and out of your VPC and within your VPC. It will look at DNS logs of what your instances and what the resources in your VPC are accessing. And it will also look at CloudTrail, which stores the API activity within your account. So if you are having a login session or somebody's using a different IP or perhaps a different country that hasn't been used before, Guard Duty is going to detect this and alert you. If your instance has unfortunately been compromised for whatever reason and is talking to a known command and control server out there on the internet, it detects that these are the built-in findings that Guard Duty has. So it's very easy to get started, one click to enable. You also want to configure application level logging. So if you're running a web service like Apache, enable Apache logging at that layer. Also operating system logs. And you can use CloudWatch logs to store those for you centralized, and then you can create alerts. And those alerts can alert you on things that are happening in there that you want to be aware of. Of course, you can use a security incident event management system, or SIEM, and this will help you centralize and correlate all the different data sources. Being proactive, well, the SIEM is going to help you be proactive. You can see what normal looks like and be able to alert when, say, a different country is accessing your workload. You also want to regularly review best practices. So we continue to iterate on the Well-Architected framework and also the blog posts that we have, a great security blog. So keep up to date with the AWS security resources, but also the industry resources. So if you're writing a language such as Python, keep up to date with the latest in the Python language, for example. So enabling traceability. As I mentioned, one of the design principles is use automation. So we can use automation for almost everything, including enabling guard duty. So we do this using AWS CloudFormation, and I've got a link to some templates on how to do that there. We can also enable customized CloudTrail logging. So even though CloudTrail is on by default, we should customize the S3 bucket and how long we want to retain those CloudTrail logs for. We also want to turn on config. So config stores the configuration history of our resources in our AWS account. So then we have a great picture of who's changed what, at what time and from where, and also what the change was. So Ben has changed to security group. This was the old setting, this is the new setting. Ben's in trouble. So for network protection, we want to start at the edge. Starting at the edge, we can use Amazon CloudFront. So CloudFront is a global content delivery network, has a built-in anti-DDoS protection as the built-in Shield service, and it provides over 100 edge locations around the world. So that's going to help you scale, not only scale your application, but also secure because it integrates with the web application firewall service. You can get started really quickly by using partner rules in the WAF service. Just enable very common partners you'll see there in the marketplace, or customize your own rules. Also, for private connectivity, you want to consider using VPC peering to peer different VPCs together, even cross accounts or cross regions. VPN connectivity from a remote site, or even a direct connect, so direct fiber to a point of presence. Also, inside a VPC, you want to think about the common security controls that you have available. So security groups. With security groups, you've got an ingress rule set and an egress rule set. The egress rule set can help you restrict what the instance, for example, can reach out to. So it can help with data exfiltration and securing that. Service endpoints provide a secure, private way of getting access to AWS services like S3 within your VPC without having to have a route to the internet. And many services like S3 have additional configuration policies within, like S3 has bucket policies. KMS has KMS key policies. So do have a look at those services that you're using and see what additional configuration that you can achieve. So let's look at network protection now. Very simple. Again, I've got a little link to a web application firewall example of how to automate. So I have example.com, and an end user is going to resolve using Route 53. So Route 53, I can do some really funky stuff. So I can route based on the origin of the country, right? So I can have multiple countries, I can have multiple sources of data, source environments, and there's a recent release of CloudFront now supports failover. So when I have an origin behind it, and I'll show you shortly, I can actually fail over the origin between one and the other. So for example, here I have a region, and I have a bucket in that region. That S3 bucket can contain static content that CloudFront can just deliver straight out of the bucket. And it saves me from having to enable public access to read that bucket in the web mode for it. I could also have a VPC within that region, and that of course has my common application load balancer behind that. So this is going to reduce the attack surface. It means my application, like my load balancer, only needs to be accessible by CloudFront and not directly accessed from the internet. So let's look at a defense in-depth approach now, some best practices. So have a think about hardening your operating system. So don't just use the default settings, customize them, harden it so it only has services and applications that you absolutely need running. So do use anti-malware and IDS, intrusion detection and prevention on instances as well. I've got a marketplace slide shortly, but there's many awesome products out there in the marketplace that you can have a look at. You want to scan your infrastructure. And again, the marketplace has some great scanning tools. You can also use Amazon Inspector to scan instances for common vulnerabilities and exploits. You also want to scan your code, and I'll show you how you can do that shortly. Scanning code allows you to ensure that, say, import validation is correct, right? Because remember, we don't just want to trust the firewall on the outside edge. We want to secure the code as well, all the way through. You also want to patch. So patching, very common, but often forgotten about. So patch everything, patch all the things. So marketplace, have a look in the marketplace for different security products and services that can help you out to get started quickly. I've got an example here of a couple of Linux instances for Amazon Linux version 2 of pre-hardened images. So all that difficult hardening work is taken care of for you, and all you pay from the on-demand price is 1 cent per hour for these couple of examples I've got here. Again, there's many available in the marketplace for all different flavors of Windows and Linux. Right, scanning for vulnerabilities. You can scan your actual code in your pipeline. So if you're using AWS tools, you can use code build and code pipeline to scan this in the pipeline for you. And remember, using CloudFormation, I can scan my infrastructure as code. And there's many great examples out there on the internet that you can have a look at. And I can scan my instances for CVEs using Amazon Inspector. And again, I can automate all this scanning. I should also test. I've got an example here of the Open Web Application Security Project, or OWASP, which is an open source project. And this is one of their great tools, ZAP, or Z Attack Proxy. So it helps you test web applications. And of course, it's free because it's open source. So do check that one out. Serverless. Everyone's using serverless now. So how do you actually secure it? And it may be that you're just running a couple of Lambda functions for automation. So if you're running an API, you really need to think about the authorization, authentication. So how you're doing that. Put a real big focus on that front of the API. Enforcing boundaries is still there. So what can your Lambda function actually access? Don't just give the Lambda function a policy to be able to access any S3 bucket. Give it a tightly tuned least privilege policy to only access the S3 bucket and lock down even the objects or the path that it can access. So that's going to significantly reduce your attack surface. Get your import validation right. So have a look at the actual code and how you're handling the import. So if you have a field that takes an email address, are you sanitizing that import? Are you actually allowing it to take JavaScript in there as well, or HTML? And you still want to protect your sensitive data. So you still want to encrypt your S3 objects, even if it is serverless. You still want to do that. You also need to think about your logs and how you're protecting your logs, because often logs contain sensitive information in themselves. So let's look at automation best practices now. So I've mentioned CloudFormation a number of times, but it really does help automate the infrastructure deployment. It allows you to have a template that defines your entire infrastructure. And of course, a template means it can be checked into source control, version controlled, and being verified, like peer review process. And then we can have this in a pipeline that automatically builds out the infrastructure that has already been verified. And of course, it's repeatable because it's a template. So my development environment can be absolutely identical with a few parameter tweaks as my production. So it also gives me a secure, repeatable way to deploy my infrastructure there. Automating that build and test process is critical. And Ivan mentioned automation earlier as well, and what NAB are doing around that. Config is a service I mentioned that stores the configuration history inside your AWS account. Config rules pick up on different settings that you configure. For example, there's a config rule for detecting a publicly open S3 bucket. I can get an alert that says someone has modified this bucket to be publicly accessible, and the config rule will pick it up and alert me on that configuration. Other built-in rules, there's many built-in rules in config. I can also configure an alert to say somebody's launched an EC2 instance with an unencrypted volume. And that goes against my security best practices and perhaps your security policy. Also, rules integrating with CloudWatch events can alert and also take automated remediation and reverse any changes in case somebody does actually make a mistake. You can automate response to events as well. I did a presentation earlier this year on automating forensics and isolation of an instance based on a guard duty finding. So that's going to help you and your security team, if you're lucky enough to have one, in having a good night's sleep instead of being woken up in the middle of the night. So how do you automate management? Well, the best way to get started would be using AWS Systems Manager. So we have automation built in. We have an agent that's baked in by default on many of the publicly available machine images now, AMIs. It also has a patch management feature, so it can detect missing patches and automate that patching process for us. It could also handle the state of an instance or thousands of instances. So I can say, when this is launched, apply this network configuration, even this hardening to this fleet of instances, and it would just automate that for us. The best thing is, I don't have to log into instances, and the templates that I use can be in the version controlled, peer-reviewed, and checked. So it's significantly reducing the human error in my workload. And here's some example config rules, just taken off a screenshot of the console the other week. So it gives you an example of just what's possible in config rules in detecting those. There's also many partners out there that do automated checks inside your AWS accounts and will give you the best practice advice as well. So let's look at data protection now. So it's important to get an understanding of the classification of the data that you're storing in your cloud. Is it publicly available? Is it top secret? You need to be aware of this. And you also need to secure your data appropriately. You can do this through using encryption, as I've mentioned. So the key management service, KMS, is built into many different services like S3, EC2, like EBS, and the relational database service. So in most cases, it's just a tick box to enable encryption at rest. You should encrypt your data in transit as well. So using TLS for web. So TLS certificates can be handled by Amazon Certificate Manager, which provides free certificates if you're using AWS services like the load balancer or CloudFront. It also automatically rotates those certificates for you. So you don't have to keep that old spreadsheet of when your certificates are expiring. It makes it a lot easier to manage those. You should also consider tokenization to replace sensitive data, even if you are encrypting it. If you don't need to store it, why store it in the first place? You're just opening yourself to more risk, more than likely from human error. You also want to think about the segmentation, like isolating data. So don't store your publicly available website. Don't run that in the same AWS account as your back-end systems. So keep them separate. You can also think about using separate KMS keys for different aspects, different components of your workload as well, as another layer of isolation. So how do you classify your data? Well, it's really good to train your teams that use the cloud to set tags. Now, you've got to be careful with tags, because in this example, I've got a data classification tag as private. But if somebody could get access, or say an insider like myself, can get access to the tags, then this tag says top secret, then I've just built myself a point to start with, right? Somebody's going to get access and see the top secret tag and go straight after that. So perhaps consider using a project code or something like that that relates back to the data sensitivity of that component or that workload. That example there is from the EBS console for the data tags. So for Amazon S3, Amazon Macy can actually automatically identify and classify that data stored for you and tell you if you have AWS access keys or potential credit cards stored in your S3 buckets. So it's really, really powerful. I've also got a link there down for IAM control as well, using tags. Keeping people away from data. You'll hear Steve Schmidt, our CISO, talk a lot about this. How do you keep people away from data? So for end users, these could be business users. We shouldn't give their business analytics tool direct access to a database in the cloud. We should give them access to a dashboard instead. So we can use QuickSight for this. Provides a really simple dashboard, really easy, click through to get started, and surface that data to them instead of giving them direct access. For administrators, I mentioned AWS Systems Manager can automate the administration tasks, as well as CloudFormation. So complete hands-off deployment, infrastructure management, all the way through. I could also use Service Catalog. So Service Catalog can drive CloudFormation, and I can also set variables like input parameters that define how the CloudFormation templates are used. And I don't need to give direct access to those users that want to stand up the CloudFormation templates. Service Catalog can take care of all of that for us. We could even give end users, like business power users, access to Service Catalog without the risk of them doing any damage in your AWS account if they don't know what they're doing. So let's look at incident response now. Who thinks they've got really rugged incident response processes? They're ready for an incident. I see maybe 1 or 2 hands. Yeah, just what I thought. It's really important to be prepared for responding to an incident. Nobody wishes that they ever have to do it, but you really need to be prepared. You should think about pre-deploying tools that can help you. So in an emergency, how do you get access to your logs to even determine if you're experiencing an incident or an event? How do you do that? You need to have those tools in place. You need to write incident response plans for different scenarios, and I'll show you shortly how you can do that. You want to pre-provision the access. So if you have a separate security team, you can pre-provision them read-only access into all your AWS accounts so they can read your logs, read the configuration in the event of an emergency. And it's going to save you a lot of time in the unlikely event that you need to respond. You should also practice this response. So practice through running what I like to call game days or simulations. You should also continuously improve your processes. So run a game day, get the lessons learned, and feed it back into your processes. You want to continuously evolve this. How do you run an incident response game day? So I've run many in the past, and I think it's really fun. You just schedule a half day or even a full day block. You get all the stakeholders in the room. So you get the developers, you get the architects, you get some business stakeholders in there as well. I like to find a prize, like bribery, some sort of bribery for the team that's involved. You're at reInvent now. There's a lot of swag. Gather as much swag as you can for those that are not lucky enough to be here with us today. Supply some junk food and beverage. I know it sounds silly, but it does actually work. And pick a couple of scenarios. I've got a link here, which is a link to the guard duty findings. So if you're not sure where to start, you can use this as a starting point. So is the EC2 instance running Bitcoin mining? Is that a likely scenario for you? So you can use these scenarios to get started with building runbooks. I'll show you what a runbook can look like shortly. Also practice. Practice. And depending on how much time you have, you can run this perhaps every month. Make it a fun event, build it into your backlog, and everyone's going to be a lot better at responding to an incident in the very unlikely event that it may occur. How do you write a simple runbook? It can be as simple as having the description, the attack type, the description, maybe link it back to a guard duty finding. How you gather the data, so which logs you need to look at, which AWS accounts, which instances, where are those logs stored? And of course, the steps to troubleshoot. If it looks like this, then it's from there, then this is how I can rectify and fix it. What the urgency is as well. And what a communication and escalation plan looks like. If you have a public relations team, how do you notify them? And at what point in that process do you notify them? And of course, it's important to get your legal team, if you have one, involved in this discussion as well and this planning. So I'd encourage everyone to take action. As Steve mentioned before, very important to take action from today's session. So we have the Cloud Adoption Framework and link to it there. We've got a link to the main page of the Wel-Architected framework. So go and have a look at the main pillar framework. It contains all those questions for security and all the other pillars, and all the best practice answers and why they're important in the appendix of it. So Wel-Architected security labs are available open source on GitHub as well, that I've linked to throughout. So you can get hands-on experience in actually implementing some of the things that I've spoken about today. Also, do keep up to date with the security blog and the security Twitter feed from AWS. and of course, your application and industry news that's out there on the internet. I want to thank you all for coming to this session. Really want to thank Steve and Ivan from National Australia Bank, and have a great reInvent, everyone.